Hello, thank you for watching. If you didn't see my high voltage generator, it was in my last video that I put on. I am building a new high voltage generator. So I got 6 stages of the multiplier laid down here, and this thing's going to be absolutely gargantuan. I didn't want it to be this way, but that's the way it's turning out. So this thing's going to chew up a lot of vector board. I'm not sure how I'm going to support the vector board because there's actually going to have to be another piece after this. I think these are 18 inches, so I'm going to need 3 18-inch pieces of vector board. These polystyrenes are very heavy, and there's going to be a lot of them. I need 12 more stages. I think what I'm going to do is maybe find something over 1/10 of an inch of G10 unclad board and see if I can find somebody to cut me some narrow strips of it. Run those narrow strips down the edges of these pieces of vector board here to tie 3 of these boards together. Originally I was hoping that my next high voltage generator would be under 30 inches in height, but I'm going to be far over that. There's really no other way to manage space on these, and the polystyrenes are just so big and heavy. So that'll set in a piece of 4-inch schedule 40. I got a high voltage probe too. I've needed one of these for a while. Some of these do 30 kV. This one here does 40. I'm very reluctant about these polystyrenes because I've tried these before on some other circuits and all the caps arced over or flashed over in the ends. So I might have just spent a lot of money for nothing. When you build these, if you're not submersing them in oil, what I would do is I would bring all the lead junctions to one spot, which I didn't do on here, and then ball solder them. That way you can get a really round connection. My connections are not close together, but ball soldering is the preferred method because you don't get corona leakage from a ball like you will if there's a sharp lead sticking out of one of these, because the ions will just scream out the ends of that sharp point, which is basically how an ion emitter works in an air ionizer machine. It's a bunch of sharp point needles that emit ions. So you don't want that to happen on a high voltage generator because you want every last bit of voltage coming out the top of it rather than leaking somewhere. Just a couple things here about ceramic caps. If I had about $4,000 or $5,000 that I didn't know what to do with, I would have all N4700 caps on this multiplier board. I think they're going to give you the best performance and longevity. Unfortunately, N4700s are extremely expensive. You could pay $50 to $100 a piece if you can even find the value and the voltage that you want. These here are Z5Us. These are the worst ceramic you would ever want to use. The temperature stability on these is very, very poor. It's not something you want to use on a high voltage multiplier. This cap here is no exception. This is a Z5R. Poor temperature stability, so the capacitance changes with temperature, and it also changes with DC bias voltage. So depending upon how much voltage you have setting on the cap, kind of mandates what the capacitance is you're getting out of it. This kind of stuff here, these are 330s at 30 kilovolts, not a cap for a voltage multiplier. The dissipation factor is very high, not good for high energy discharge, and these are a class 2 capacitor. What you want is a class 1. Now this one here is a X5F. Class 1s would be your NPOs, your COGs, your N750s, your N4700s would all be class 1. So just something to keep in mind if you want to get a lot of bang out of it. I'm not saying the caps won't work. I'm just saying they're not going to perform well. Now these polystyrenes, I think it's fair to say these would be a pretty excellent choice. But I think these caps are going to flash over in this. The dissipation factor on these would be very low. And if they don't flash over, they're going to give you a lot of good bang to them. Perhaps more so than what a ceramic might even. But just some things to keep in mind from the few things I've learned over the years about these voltage multipliers. Also too, many years ago I built a load can for a laser power supply, but I never built a load can for a flyback oscillator. So I'm going to do that. I have 80 of these resistors. These things here are hard to find. These are 3 waters. They're 1.19 meg. Excellent for making a load can. So when I series parallel all these up, I'll have a 240 watt load can at something probably around 500K or a little bit less. And I'll probably sink that down in a polypropylene paint can. So I'll be able to check my flyback oscillators to see what they do under load. Very reluctantly, I'm using some diodes that I bought on eBay. I always told myself I'd never build another HVG unless I could get Vero diodes. But you just can't get Vero stuff anymore. These are much, much shorter than what the Vero diodes are. I have no idea if they'll even survive. The Veros are fully avalanche rated. So what that means essentially is when a big, huge transient comes around, the avalanche diodes are very resilient to a voltage exceeding their peak reverse voltage. So that's something you want to look for. A diode that is avalanche rated. These are 20 kV diodes, and these are really small compared to the Veros. The Veros are probably, definitely 2 times this long, probably 2.5 times longer. You could easily have several thousands of dollars tied up in a multiplier, but I would definitely recommend an N4700 Class 1 ceramic. I may have bought something that's going to be completely useless, but only time will tell as to whether or not these will flash over too. So thank you very much for watching. Have a good day.